Alright guys, so this is the video for section 11.4, and this is kind of shorter and quite not as mathy. It's more vocab stuff, so hopefully it'll be easier for you. Alright, so just a reminder, a polygon is a plane figure, and when I say a plane figure, it's a figure you can put on a plane, so like on a sheet of paper. So we're talking about 2D, okay, two-dimensional, enclosed with sides and angles. Okay, so given this description of a polygon here, we're going to go through and determine if these three are polygons. Okay, so it says use the above definition to determine if the figure is a polygon. If not, explain why. All right, well, a rhombus, it's two-dimensional, yes. It has sides, yes, it has 4 of them. And it has angles, yes, it has 4 of them. So this would be a yes. Okay, a circle, on the other hand, is it a plane figure? It is a plane figure, it's 2D, but it has no sides and no angles. So a circle is not considered a polygon. I'm going to put no sides / angles. Okay, and then a rectangular solid, is it a polygon? Well, a 2D figure, no, this is 3-dimensional. So no, not 2D. All right, now let's move on to the next page, okay? Or the next slide, I guess. So a polyhedron, this is just more vocab, is now a 3-dimensional figure that's bounded by polygons. So it has nothing but polygons in it. Okay, so if we look at this, see, this is made of a bunch of rectangles, and then here's a trapezoid. So this would be considered a polyhedron. Okay, now the parts of a polyhedron, we have the face, the edge, and the vertex. Okay, so the face is just one of the flat surfaces. Okay, so think of a face as like this entire top part here. Okay, so these would be the individual polygons that make up this polyhedron. Okay, so there's several faces on every polyhedron. Okay, now an edge is actually a line in which 2 faces intersect. Okay, so if I were to go and highlight this face too. Okay, so there's 2 faces that I just highlight. Notice that they intersect at this line right here, this crease or this fold or whatever. Okay, this would be an edge. The whole line there would be an edge. Okay, and then the vertex is where 3 or more faces meet. And here we're talking about points, okay? So just like normal shapes of vertex, this would be a vertex, this would be a vertex, 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 all the way around. So there's several vertices too. All right, so some polyhedrons are prism and pyramid. They're the main polyhedrons we're going to talk about. And so a prism is defined as a polyhedron in which both bases are congruent and parallel, and the faces are always rectangle. Okay, so this polyhedron shown here would call, here's a hexagon base. Okay, this is the base. Notice it's congruent and parallel to this hexagon base. And then we have all these rectangular faces. And we label prisms by their bases. So the base of this is a hexagon, so we would call this a hexagonal prism. Okay? If the base was a triangle, we would call it a triangular prism. Okay? So just know that we always name these by their base. And same thing with pyramids too. Okay? So a pyramid is an object which has a polygon at a base, and it meets up at the top at, some call it an apex, some call it a vertex. You'll see both of those, okay? And so once again, here's our base, and in pyramids, the sides are always going to be triangles. So here's a triangle, here's a triangle. That's true for all pyramids. And pyramids are also named according to their base. So I could call this a square pyramid. assuming that that's a square. I probably shouldn't assume that. Or like a triangular pyramid or rectangular pyramid, octagonal pyramid, either of those. All right, so non-polyhedrons, guys. So the first non-polyhedron is a cylinder. So it is a non-polyhedron. And in a cylinder, the bases are circles that are congruent and parallel. Okay, now a cone is also a non-polyhedron. The base is a circle, and the sides converge to a vertex or an apex. So this is the same thing as a pyramid, except now we have a circular base. Okay, a sphere is also a non-polyhedron in which there's a center, and three-dimensionally, every point on this sphere is equidistant from this center. All right, guys, so here's just kind of a visual of the vocab we talked about. Now, these come in all different shapes and sizes with different bases and this and that, but this is just a general idea. All right, so let's look at example 1. Okay, it says, tell whether each solid is a polyhedron. If it is, name it. All right, so when I look at this one, the first thing I want to do is I want to find the bases. These are the bases, because these are the congruent and parallel endpoints, if you want. And yes, this is a polyhedron, and we would call this a rectangular, because the bases are rectangles, prism. Because of the rectangular sides, these are prisms. All right, if I look at this, I have a pyramid, and pyramids are polyhedrons, so this would be another yes. I have a something pyramid. And once again, we label pyramids by their bases. So this here would be its base. Okay, so I'm going to mark, or I'm going to number the vertices here. So 1, 2, 3, 4, 5, 6. So there's 6 vertices in this base. So that's a hexagonal pyramid. Okay, last but not least is this cone. This is not a polyhedron because this is a circle and a circle is a polygon, and polyhedrons are made fully of polygons. All right, so let's go to example 2 now. But before we can do example 2, we have another vocab, a cross-section. Okay, so a cross-section is just the intersection of a plane and a solid. So we're just going to like slice through something and see what shape it makes. Okay, so if you look on A, we have this polyhedron, and then this rectangular thing, we're cutting through that polyhedron. And when we cut through it, notice you can see, it's kind of hard to see on black and white. This is kind of shaded in black, 1, 2, 3, 4, 5, 6. So what we'd get, and we just want a plain figure, is a hexagon. Okay, we're just getting a flat hexagon when we cut that into that. That's what we see. Okay, now on B, if we cut into this pyramid, we get this right here, which is just going to be flat, which is a triangle. And when we cut into the cylinder here, we get this right here, which is just a rectangle. Okay, I want you to go ahead and do these 3 on your own, and then we'll go over them. All right, so D and E should have been pretty easy. Both of those were circles, and then F might have been a little bit harder. So when we do that, we would get this shape right here. And because the bases are parallel, that would be a trapezoid. All right, so we have a couple more vocab words. The axis of revolution and the solid of revolution. Okay, so think what the word revolution means. Okay, revolution basically means to go around. So one time around completely. All right, so the axis of revolution is just the line in which a shape is, I'm going to put revolved around. So we're going to go around it, okay? Over and over and over. We're going to go around it. And then the solid of revolution is the three-dimensional figure formed when we rotate a two-dimensional shape around an x-axis. All right, so let's look at these examples. Okay, in this example A, right here would be our axis of revolution. Okay, and this triangle up top would be our 2D shape. So if we took right here that's connected to the axis of revolution, if it stayed connected to the axis of revolution and we revolved it around this axis, what we'd get, and I'm a horrible drawer, is something that looks like this. We would eventually, when we do that, go around, we would get a cone, right, where the base has a radius of 3, and the height from the radius to the apex is 4. Okay, so let's look at B. So here's our axis right here going up and down. This is our figure that we're going to revolve around this axis. So we're going to go around it. It would look like this. Once again, sorry for my art. And what would end up getting is a cylinder whose base has a radius of 6 and a height of 8. Okay, now on C. Here's our axis right here, and we're going to revolve this triangle around. So when we go around, we're going to do this. Okay, so we're going to end up once again with a cone, and the base has a radius of 2, and it's going to have a height of 5. All right, I want you to go ahead and do D and E on your own, and then we'll go over it. All right, so on D, you would end up getting a cylinder. It looks something like this. The base has a radius of 4, and the distance between the bases is the height, which is 9. Okay, and over here on E, we would actually have a sphere, and this sphere has a radius of 7, and that's all you need to know.